All right, let's talk about the secret behind every great piece of software you've ever used. And spoiler alert, it's not just about fancy code. It's about having the right blueprint before you even start building. So today, we're diving into the world of systems analysis.
Oh, you know the feeling. We've all been there, right? Tapping away at a screen that just won't respond, waiting forever for something to load, or trying to figure out a menu that makes absolutely no sense. It is just so frustrating. But where does a problem like that actually start?
You'd probably think, oh, this must be some terrible programming. But honestly, more often than not, the project was doomed from the start. The real failure happened way earlier. It was a failure in planning, a failure in understanding, a failure to ask the right questions before anyone even opened a code editor.
And that, my friends, is where systems analysis swoops in to save the day. Think of it as the ultimate cure for software chaos. It's the second major phase in any software development project, and it's all about one thing: creating a rock-solid foundation by understanding the problem inside and out.
So, let's pull back the curtain and see what happens in this absolutely crucial phase long before a single developer starts typing. This is where the real architectural work gets done.
So what's the game plan here? Well, it's pretty straightforward. First, you have to truly understand the system you're working with, warts and all. Then, you pinpoint its weaknesses. From there, you figure out what people, the actual users, really need. You use that to set crystal clear goals for the new system, and boom, you prepared a solid foundation for the designers. It's a structured path to success.
The whole thing really kicks off with an investigation. Seriously, the systems analyst basically puts on their detective hat to figure out what's going on at the scene of the crime, which, in this case, is the clunky, inefficient system.
And this whole investigation really boils down to two key things. First, you've got to clearly identify the problem you're trying to solve. And second, you have to figure out if it's even possible or smart to solve it.
Okay, to make this real, let's imagine we're building a new hospital management system. The initial problem, the thing everyone's complaining about, might be as simple as this. It's a bit vague, sure, but it's our starting point. And that's step 1, problem identification.
Now, it's time for a major reality check. Just because you've found a problem doesn't mean building a brand new system is the right answer. This is where the feasibility study comes in. It asks the really tough questions. Do we have the tech for this? Can we actually afford it? And maybe most importantly, will the hospital staff even use it? The result is a report that leads to a simple but critical go or no-go decision.
So, let's say the project gets the green light. Awesome. Now the deep dive begins. This next phase is all about gathering the facts and understanding every single little detail of how things work right now.
And again, this breaks down into two main jobs. First, you go out and gather every piece of information you can get your hands on. Then you have to sit down and actually make sense of it all. So how do you get all this info? Well, it's classic detective work. Analysts will interview nurses about their day-to-day headaches. They'll literally sit at the front desk and just watch the current patient registration mess happen in real time. They'll dig up old paper forms and maybe even send out questionnaires to the whole department.
And here's the kicker. Just having a pile of data is useless if you don't interpret it. In step 4, the analyst sifts through everything to find the root cause. It's not just that registration is slow, it's slow because there's a huge bottleneck in the manual data entry process. Nailing this diagnosis is everything.
Okay, we've diagnosed the problem. Now it's finally time to design the solution, but on paper first. This is where all that research and analysis gets turned into a concrete plan, our blueprint.
This last big phase of analysis has 4 steps, and these steps are what take us from just a bunch of ideas to a final approved plan that designers and developers can actually build from.
This brings us to a super important step, defining requirements. They come in 2 flavors. First, you've got functional requirements. This is what the system must do. For our hospital, that's something like the system must let patients book appointments online. Then you have non-functional requirements. This is how the system must be. It has to be secure, obviously, to protect patient data, and it needs to be fast, like pages load in under 2 seconds. You absolutely need both. One without the other is a recipe for disaster. Now, to make sure everyone's on the same page, analysts don't just write long, boring lists. They draw pictures. Step 6 is all about creating visual models, like a data flow diagram. Think of it like a map that shows exactly how information, like a new appointment request, is going to travel through the hospital's shiny new system.
And all of this hard work, the investigation, the fact-finding, the requirements, the models, it all comes together in one single, incredibly important document, the System Requirements Specification, or SRS for short. This is it. This is the official blueprint, the holy grail that everyone on the project will follow.
Okay, let's pull all that together for a second. This table basically shows the entire 8-step journey we just took. You can see how we start with a really simple problem definition in step 1, and then through all that analysis and modeling, we end up with that final sign-off in step 8. Each step has a clear purpose and creates something real that the next step builds on. It's a structured path from a vague complaint to a concrete, buildable plan.
So, after all that, you might be wondering, why go through all this meticulous, time-consuming work? Well, the answer is simple. Because getting this analysis phase right is probably the single best predictor of whether a project will succeed or fail.
And the payoff is absolutely huge. It makes sure you're building what users actually need, not just what you think they need. It massively cuts down the risk of failing spectacularly and going way over budget. It helps users and developers actually speak the same language, and it creates that unshakable foundation for the entire project.
And this right here says it all, doesn't it? Trying to build software without proper analysis is exactly like trying to build a house using a drawing on a crumpled napkin instead of a real blueprint. You're not an architect at that point, you're just guessing with very, very expensive materials. And the result is almost guaranteed to be a mess.
So here's the big takeaway. Great systems aren't just coded. They are carefully, methodically analyzed and designed. They're born from a deep, deep understanding of a problem. Which leaves me with one final thought for you. What broken, inefficient system in your own life is just waiting for someone to drop its blueprint?